Hello, community. Last time we were talking about GPT-4 and I showed you two plugin integration. We were talking about OpenAI APIs, and in particular, we were talking about the technical details about OpenAI's Retrieval plugin. And I told you in the next video, we're going to look at a dynamic flow of data between all of those constituents. And today is the day. So here we go. We start our dynamic system overview with GPT-4 and we focus on OpenAI's original Retrieval plugin. We're going to talk about the embedding machine and about an external vector database or a vector store. And I'm going to visualize the dynamic flow for you so that you clearly see what data moves between which element of the system. So let's start. We have a user and a user has a prompt to the GPT-4 system. Now, GPT-4 has a lot of internal knowledge learned, but maybe not an answer to your particular query. So we need another plugin from OpenAI. We use here the Retrieval plugin from OpenAI. And this Retrieval plugin comes with additional OpenAI model. And this is now the text embedding ADA 002 model. This is our embedding machine. This is our GPT-4 machine, if you want. So you have now two different distinct models from OpenAI that we're going to use, plus the OpenAI plugin. And of course, as I told you, we want to store this information outside of GPT-4 because we do not have access to GPT-4. We're going to use here a Postgres. And of course, we want to have here our domain-specific documents. Either it's your private documents or you're a company, you're an enterprise. You have maybe your private, secure, domain-specific documents. You want to query now and you want that GPT-4 gets access to this data it has not been pre-trained on. Beautiful. So let's have a look where we are. We have two models from OpenAI. We have a plugin from OpenAI. We have enterprise corporate files. Those are my files, for example. And then we have a cloud solution either from Microsoft Azure. It's called Cognitive Search. I showed you in my last video. Or we go with AWS, also with here Postgres and the pgvector extension. Or if you like, I have here two open source possibilities, Viviate and open source vector search engine. You can also host locally, or Milvus and open source cloud native vector database. Whatever solution you choose, it is up to you. If you want to pay, if you want to build an open source system, those are our main components. Beautiful. So, first task, we have now the information that is in my corporate files. We have now to fill up this information into our vector store so that we have valuable and new domain-specific information available for our plugin. So how we do this? Remember I told you there's 4 beautiful and friendly OpenAI API endpoints. Now we use here the endpoint upsert to have here our first document read into the plugin. Now what does the plugin do? The plugin says, hey, great. So I have here a string of human language. I have converted this that I can use it for my semantic search into a vector representation. Therefore, I know I have access to here the specific model by OpenAI called text embedding ADA 002. And I'm going to use this to create now the vector embeddings of the content of this document. How is it done? If you code it, easier. 2 lines of code. You have OpenAI embedding create, you have your input sentence, whatever it is the sentence. You define the model, as I showed you, text embedding ADA 002, and you get back a response by the system, which is an embedding vector. Please note that this embedding vector has 1536 dimensions. So 1536 values here within your vector representation of this particular sentence. Now, I got a lot of questions what is the optimal length of my encoding? It depends here, of course, on the information density of your set and the resolution you want to achieve here with your embedding. As I told you, the maximum input length of the text embedding Ada 002 system is more than 8,000 tokens. So let's say about 2,000 words. So you can here really easily embed complete paragraphs or maybe even short documents. But you have to think about, is this the right solution for the task that you want to achieve? If you want to go and only have single sentences, because you think about the self-attention mechanism and the beautiful transformer architecture where you can encode here the relation, the semantic relation of each single word in a sentence to other words in this sentence, maybe the best solution for you might be to go, like here in this example, with sentences. Beautiful. Now we have here, as you can see, a vector representation of our text and our text. And both elements, remember we have here the pgvector extension of our Postgres, and this allows us to store here the vector representation of these particular sentences of this particular document. Great. Now, next step is OpenAI Retrieval plugin requests now some external information in order to answer my query. So now that our vector store, our Postgres has now, let's say, is filled up with all the valuable information from my documents, my domain-specific information. So the vector store is encoded and loaded. And now I come with my query and I say, hey, GPT-4, tell me about. And GPT-4 has not the knowledge, but needs an external data source, and it has access to this external data source with a Retrieval plugin. So as you can see here, I used the mere prompt here, tell me about physics. Now let's say that physics was not a topic GPT-4 has been pre-trained on. So it needs additional information to answer my query. So we have here physics coming into one of those 4 friendly API endpoints of our plugin. And you know it is the query endpoint that we're going to use now for our query. So this plugin says, hey, I have now physics. So again, what I do, oh yeah, before the embedding machine. I got a lot of questions about what is the best embedder. Now, it depends on your task. Let me show you this. If you check the knowledge base of your embedding machine, it will show you on what data it has been trained. Now, very easy example. This OpenAI specific text embedding Ada 002 model has been trained for everybody. So it has to include a lot of topic, news, politics, finance, lifestyle, beauty, I don't know what. And then, if we are lucky, it knows about physics because it copied more or less, hopefully, the complete internet. Now, if I have now my physics question, so if you say the whole embedder has a size of 100, let's say physics now has about 10% I use now of the complete available space. Now you might say, I have so complicated question in physics, I need a better resolution. So I construct now my own embedder, and I have the first topic of physics, the second topics of physics. As you can see, this is an embedder optimized for my content. And I have only physics. I want to know nothing about news, about politics, about finance. I don't need this information. I have my specific domain-specific embedder. And when I say I get a better resolution, now you know what I mean. I can pinpoint in much more detailed specific topics. If you are in medicine, this is helpful. If you're in chemistry, this is helpful. My goodness, even if you are in, I don't know, in law, and you are an agency and you have 40,000 cases, and you just want to have the perfect embedder only for your law company, you build your own embedder. Okay, beautiful. So as I told you, we have physics now here in our query plugin. And here's our query plugin. And the query plugin says, hey, I have now to access the vector embedding representation of this human language string. So what I do, I send it over to here, our embedding machine. My word is physics, and I need now the vector representation of physics. Now I get this representation. I have so now the human text and the vector representation based on the training of my embedding machine. And now you're gonna see what's gonna happen. I have now my query that I have here, ask GPT-4, not only here the plain English text, for example, but I have here now the vector representation for a semantic search. And I have here, and there's just one depicted, one vector for one particular sentence in a document or a paragraph in a document. And now if I have, instead of one, imagine I have 100 or 1000 or 10 million vectors here in my Postgres. And with the new pgvector extension, you know what's gonna happen now. Very easily, if I only want to have here the semantic search function, I calculate now the cosine similarity between two vectors easily. Between this vector and 10 million other vectors. It takes about 5 seconds. Great. Now, if you have here another example, let's say we'll just look now here at this particular case. So, hybrid database systems. They are beneficial in specific instances. Let me show you a business example. You are a bank and you have 100,000 clients. And you have now a query that you have for GPT-4 is, hey, can I give a new credit for Charlie Brown? Let's say this is a particular person. Now what you do? Theoretically, you can have now Charlie Brown instead of physics encoded. And if you have 100,000 clients, you go now and search here a cosine similarity of a vector operation on more than 100,000 clients, and each client has about, I don't know, a particular file with 1,000 sentences. So you have to do a lot of query. The nice thing is, hey, we have two unique identifiers, Charlie and Brown. So we do not start with the semantic search, but in a hybrid system, like in AWS or in Azure, you find now the complete file or multiple files of Charlie Brown. So you reduce your search space for your semantic search with a hybrid system to just, let's say, one file of Charlie Brown. Now, this hybrid system returns now one specific document. Here it is. And let's say this specific document has 30 sentences in it. And one of the sentences is exactly the information you're looking for, the income of Charlie Brown. And you need now the income of Charlie Brown to determine today, on 8 o'clock, to determine if you can give him a credit, yes or no. So you need this information. So now on this document here, and this now is here our document from Charlie Brown, and only the document from Charlie Brown with 30 sentences, so you have 30 vectors. And now you calculate here a cosine similarity mathematical function between your search vector and your document vectors, 30 document vectors. And let's say there's in one sentence, so one vector gives you, hey, here's the information, the cosine similarity. Here is it. Beautiful. Now we go back to our system. Now you see what you get back from Postgres now after this is not all files, but a very particular file, or maybe even just a paragraph of one file, or maybe even just one sentence of a file. And this I indicate here with this symbol. So what happens now is I have my query, and I provided from my Postgres cloud-based yes or no additional information that I chosen because I was able to perform a hybrid search and then a semantic search. And a piece of information is not a vector I give back. This is a human readable sentence. Now, normally we just don't return one piece of information, but we return from the cosine similarity operation, for example, the top 3 results. Because maybe it is in the second, or maybe it is in the third document. So you can say 5, but default is with OpenAI 3 documents or pieces of documents. Now to the question, how long does this document have to be? Listen, it can be a sentence. If you're looking for one particular fact, you just need to return one sentence or one paragraph. You do not need to crush the 33K token length threshold. Nonsense. 500 tokens are enough for the information you need. So, beautiful. This now is our new piece of information that belongs together. We have the query term that I was looking for, and I have the human readable information, the additional information from today, 8 o'clock in my bank office, and I get exactly the data that I need to answer now the query. And these are external data that GPT has not been pre-trained on, and GPT-4 had no access without our plugin and without our semantic search. So you see, you can search now your private secret company data files on your company server, provide only this piece of information that you need about Charlie Brown and not your other clients. You do not have to upload all your clients to GPT-4, but you just give this single sentence where the information you are looking for is included. And voila, here we have it. Now my prompt about physics or Charlie Brown is now here a new prompt after performing all this operation. So in human language, because GPT-4 is a large language model and not a vector machine, in human language, I have now my query term and additional information. And no vectors, please. So I want to show you this in the developer settings. This is from Microsoft Mechanics, copyright Microsoft Mechanics, beautiful. And here you see the reply. You have a specific question. And then you have now, coming back from, this is Microsoft, so it's Azure Cognitive Search, reply now 2 documents. The Northwind Standard PDF and the Northwind Health Plus PDF. And you see there's, let's say, 1 paragraph or 2 paragraphs, I don't know. As I told you, 1, 2, 3. And now we have here this additional information. If you look now at the prompt structure in the internal workings of GPT-4, you see here, you have here now the new prompt. And it tells GPT-4, hey, you are an assistant, you help company employees with their health care plan question and question about employee whatever. Answer only with the facts listed in the list of sources below. So you give the command to GPT-4, only the sources that came back from cognitive search. You use only those sources. And if there's not enough information, you say you don't know. You do not generate any answers that you do not use the sources below. So it must come from the solution space of the sources, from the sentences here in the sources. If asking to clarify a question, ask the question. Each source has a specific name, so you have really an indication where the solution came from. Always include the source name for each fact you use in the response. You can use brackets, whatever. So you see, this is the internal workings. We look deep into GPT-4, how it works. If you have a question, it goes there, it finds the additional information outside of GPT-4 in Azure Cognitive Search, where you uploaded your document, and only the pieces, let's say you have, 1 million document, and you only have, as you can see here, 2 documents that come back with 1 paragraph. So do not make the mistake that all 8 million documents come back in the prompt. That's nonsense. The machine would not be able to handle this. You only come back with the paragraph where you think, or the machine thinks, based on the semantic search, that the solution to your question is in. Beautiful. Yeah, some important points. I got some questions from my viewers here about the embedding machine and the vector database. Compatibility issues. Now let me say this very clearly. Your vector embedding machine, this here, my text embedding Ada 002 model from OpenAI, encodes your query that you have to GPT-4 and please, and the content of the vector store. So whatever you fill into this vector store, it has to be the absolute same model that encodes your query in a vector representation. Let me make this clear. This here is the only vector embedding machine you can use if you perform a similarity operation, because it has to have the same base on the query and on the answer. Otherwise, they won't fit together. You are in big trouble if you use some embeddings from a vector searcher engine or a vector store provider, and you encode your query, let's say here with an OpenAI vector embedding machine. They won't fit. So there's only one source for the query embedding and the answer embedding, or the Postgres encoding, the content of your vector store. Does it have to be OpenAI? No. Does it have to be GPT-4? It is never GPT-4. It is text embedding Ada 002 model, not GPT-4. Okay, absolutely clear about this. Hey, let's create our own plugin. 7 steps. Create a managed database instance. pgvector, I told you. Set your environmental parameters for all the different databases, for all the ports, for all your passwords. Initialize a script to set up the table. Run the plugin locally. There is something like Poetry, a Python dependency management tool. And add content. Look, here. Here is my text. It's 1 sentence. Azure databases for Postgres support Postgres. Wow. This sentence I have now encoded and integrated here in my Postgres SQL. This is it. Then you register your local plugin with OpenAI and you're up and running. If you want to have all the technical details, here is your HTTPS link where you can have a deep dive into the code for days and weeks. Last wording, you pay. You pay for every step, you pay for every model. I want to make this absolutely clear. You pay for the model from OpenAI that is called Text Embedding Ada 002. You pay for access, input, and output of OpenAI GPT-4 model. And if you have any kind of vector store, any kind of vector database representation, any kind of cloud-based, Postgres, you pay. This is important to understand, and sometimes, yeah, you even pay for third-party plugins. So be aware how the system looks like, how the data flow is, and what you pay for. Beautiful. Now, if you're interested that you combine now the vector embedding machine here with this vector database, there's an easy solution. I show you how you can cut off here the middleman and build your own coherent system where more or less you only will have to pay for GPT-4 input, output, and access. But those two elements we can build ourselves, and I think this could be the topic of one of my next videos. I hope this video was informative for you, and I hope to see you in my next one.